Hello, good afternoon, students. I am once again Professor Dr. Saza Ali discussing about the NEET classes, chapter number 4, alternating current. In continuation to the previous lesson, we will discuss about power dissipated in pure resistor or resistance. We know that power is the product of instantaneous EMF and instantaneous current. Assuming that the instantaneous EMF is equal to E maximum sin theta and current is I maximum sin theta, then P will be equal to E maximum I maximum sin square theta. You can write. If you substitute sin, theta will become the square of theta. Anyway, whether it is analytical or graphical, in the graph you are having E as the instantaneous EMF, the firm line which is showing, and the dotted line is for the current. So that shows that the voltage and current, they are in phase with each other. Why? Because the starting time of the current and voltage is same, reaching to the maximum and 90 degree is also same, coming back to 180 degree similar, reaching to negative maximum at 270 degree is same, and coming back to 360 degree to 0 is also same. Therefore, they are said to be in phase vectors. Voltage and current, they are in phase with each other. The meaning is the angle between voltage and current will be, or EMF and current will be 0 degree. That's why they are called as the in phase vectors. So the product of quarter pulse of the current and quarter pulse of the voltage or EMF, if you multiply together, a peak power pulse you will be getting. That is the active power, or that is the power dissipated in the pure resistance. And logically, you can see here, power dissipated is always alternating power, that too dissipated is always Vi cos phi, active power, which is called as the active power AP. And power developed in the resistance, that is Vi sin phi, that is the reactive power which is measured in volt ampere or kilovolt ampere, whereas the active power is measured in watts or kilowatts. Active power or real power or true power it will be called, and this is the wattless power or reactive power it is called. S is called as the apparent power or the total power. You can say three types of the power it will be having each element, whether it is resistance or inductance and capacitance. When they are subjected to the AC sources, they will develop three types of the power. Active power is called as the dissipated power, that will do the work, whereas the reactive power, which is denoted by Q and expressed as Vi sin phi, is measured in volt ampere reactive or kilovolt ampere reactive, whichever is necessary. That is the reactive power, whereas the apparent or total power is the product of actual voltage as well as the current. Here, active power P is equal to Vi cos phi, or otherwise, in such case, it will be also I square R. Why? Because cos phi angle is 0 degree here. Cos 0 is 1 multiplied by anything will be remaining same as it is. Therefore, Vi you can take just like the ohmic power, or I square R also you can declare, or you can declare as V square by R also. Three types of the power equation you know from the Ohm's law. The same will be applied here. But you know that if the phase angle is 0 degree, if you are considering sin 0, Sin 0 is 0. 0 multiplied by anything will be 0. It means the reactive power will be 0 in case of the pure resistance. There is no reactive power in case of resistance. And here apparent power is the vector sum of active power and reactive power. So if you substitute the value of P square, whatever the value you are getting, that is what square it will be taken, whereas the Q is 0, 0 to the power of 0 only. If you have taken the root, once again S will be equal to P only. So here the apparent power, which is the vector sum of the active power and the reactive power, will be a active power only. Why? Because reactive power is nil in this case. So this is the theoretical explanation of the power dissipated in case of the pure resistance. Analytical proof also I will give you just after discussing this. Thank you.